So you've made it to part 3 of Rational Functions, chapter 8-5 from your textbook. I promise this video is not going to be nearly as long as the video from yesterday. I know that one was just never ending almost. Okay, so let's just summarize what we talked about. Surprisingly, all the information from the previous video fits into these 3 little spots. So remember, the vertical asymptote is when denominator equals 0. The horizontal asymptote is for the bobobotinide. Bigger on bottom, y equals 0. Bigger on top, no horizontal asymptote, but check for slant. And if it's equal, you'll divide the leading coefficient. So that's talking about exponents for horizontal asymptote. Slant asymptote, if the degree on top is exactly 1 more than the bottom, use synthetic, ignore the remainder, and you've got your slant asymptote. X-intercept is when the numerator equals 0, and y-intercept, you just plug in 0 for x into your equation. So there's your bobobotinide right there. And then finally, to graph rational functions, you'll want to sketch in the asymptotes, then pick a couple values on each side of vertical asymptotes and plug them in the function to graph. And you've got it. So let's talk about one last thing whenever it comes to rational functions, and that is holes in a graph. And so I had briefly alluded to it before, but it's whenever you have factored everything completely and something cancels. So let's see. In some cases, both the numerator and the denominator of a rational function will equal 0 for a particular value of x. As a result, the graph will be undefined at this x value, because remember, anything that is 0 in the denominator will make it undefined. But if this is the case, the graph of the function may have a hole, and a hole is an omitted point in the graph, which we would note with an open circle. So let's look at this example. Whenever you factor the numerator, so here I've got a difference of 2 squares. I've got x minus 2 and x plus 2. So just like we did before when we simplified rational expressions, we would cancel out whatever matches on the top and the bottom, and that would leave us with x minus 2. So if you take the thing that cancels, here it was the x plus 2, and you take the thing that cancels, you set it equal to 0, and you solve, that's the x value for the hole in the graph. And then you would draw on your graph, so whatever was left over, we have x minus 2, so that's the graph we're going to make, the line x minus 2. But the hole is at x equals negative 2, so we go to negative 2, erase that spot, and put an open circle there, and there's the hole in the graph. So let's look at another example that doesn't have so many 2's in it, because I feel like that one makes it a little bit confusing. So we want to identify the holes in the graph for this function. So first of all, let's factor that numerator. So it multiplies to negative 6 and adds to positive 1. Well, that's x plus 3 and x minus 2. So you have over x minus 2. So to simplify this, the x minus 2's cancel. Now we have f of x equals x plus 3. But there will be a hole in the graph at, so we have the thing that canceled was x minus 2. If I solve for x there, that will give me an x value of 2. To figure out the y value, you just plug that 2 back in, so 2 plus 3 is 5. So there's going to be a hole in the graph at 2, 5. So let's graph this. So here's our graph for the line x plus 3. The y-intercept is at 3, so we go to positive 1, 2, 3. There's a point. Slope is positive 1, so we're going to go up 1, over 1, up 1, over 1, up 1, over 1. But we have a hole in the graph at 2, 5. So even though we sketched this in like that, we actually need to go back and put a hole in the graph at 2, 5. So I'm going to 2, 5, 1, 2, 3, 4, 5. I'm going to erase that point right there. I'm going to put an open circle instead. And so I've got, come on, open circle at 2, 5. Looks a little silly, but that's it. And by the way, on a graphing calculator, if you were to try to look at this, you would not be able to see the hole in the graph unless you were looking at the table, because it really is the point all the points up to 2, not including 2, but 1.99999 repeating forever until infinity is included. So you're never going to be able to see with your own eye the actual break in the graph there, but that's how we're going to graph it so that we understand that there is a hole in the graph there. Okay, that's it. See, that wasn't bad for the last video. You got the worst part done yesterday. All right, so I will see you in class. Hope you're having a good day. Bye.